It does not cross the y-intercept, or sorry, the y-axis, so there's no y-intercept. Let's do some end behavior. So I've got to figure out what happens to the right side of the graph and what happens to the left side of the graph. So here is the ending of my graph. It goes on forever, but end behavior, that's the end of what I know. So that's on the right side. I'm going to say as x goes to infinity, that's the right side. Then I got to figure out where the y's are going. So as x gets bigger and bigger and bigger, if he wants to find the graph, he's going to have to look down because that's where the graph is heading to. Because he has to look down, that means it's going to negative infinity for the y's. Now the other end of it, as far as the left side, normally we would say negative infinity, but the problem is that this guy stops at 2, right? This value is as far as it can go. So we would just say as x approaches 2 this time, and then you have to decide what f of x approaches. Well, at that point, 2, 0, as x gets closer to 2, well, what's the y value at this point? 0. Okay, increasing and decreasing, or sorry, even, odd, or neither. If you fold this in half down this middle line and flip it over, it does not produce the same graph at all. In fact, it's completely backwards, right? Wrong quadrant. Odd would be if I put a pin in the middle and I rotated the graph 180 degrees. Would I get the same? No, you just end up with something over here. So in this case, it would be neither. Okay, increasing and decreasing. Now, when you look at this graph, it always starts at the leftmost point. Since we start at 2, then here's my choo-choo. See if I can clean up some of this. So my choo-choo is going to jump on the train right here at the farthest left point. Right? Choo-choo! And he's riding along, and you ask yourself, is he going uphill or downhill? He's going downhill. That means that portion of the graph is decreasing. So this interval right here from the starting point to infinity is going to be decreasing. So you look at it and you say, oh, the starting point was at 2, and it went on to forever at infinity. They're both parentheses because you are not including the point 2 because it's not doing anything at that point. Okay, so how about increasing? Well, if the whole function is always decreasing, then it's never increasing, which means there are no extrema. Remember, the definition of extrema is when it changes from increasing to decreasing or vice versa. If it is always decreasing or it's always increasing, then there are no extrema. Okay, this one, 2x cubed plus 3. Let me get you a graph. Okay, so beautiful. Tell you what. Okay, let's talk domain. I probably need my little bar here, make it easier on us. Oops. Hello. I picked you up and said, let's go. All right, domain. So I'm looking at left to right. Okay, taking my graph. I'm going to the left, to the left, to the left. Do I reach the end of the graph? Technically, no, because this guy is going on forever and ever and ever. So the domain's going to be from negative infinity, clear over here. Okay, and then I'm going to move that guy over to the right side and say, where do my x's stop? Well, my graph hasn't stopped because it goes on forever, which means my x's will never stop. So my domain is from negative infinity to infinity. Okay, what about range? Now we've got this line, but we're going down and up. Straight, that's okay. So start somewhere in the middle of the graph, doesn't matter where, and just move that line down and tell me when I run out of graph. Nowhere, right? So it would go down to negative infinity, and then it would also go up and go on forever. So the range is also going to be negative infinity to infinity. Okay, looking at the graph, we need to know where it crosses that x-axis. and where it crosses the y-axis. The y-axis is pretty obvious. Right there, correct. And those coordinates are 0, 3. So y-intercept happens at 0, 3. Now as far as the x-intercept goes, it's going to be at -1.5. You can zoom into the graph and look at it. That's about where it is. It's -1.5. Okay, so -1.5, 0. Okay, whoops, sorry about that. It's not at -1/2, it's at -1.145. I forgot to cube root the sides. So on the graph, it tells me right there it's -1.145. And that's the whole point of this unit, is that you can look at the graph and find everything you need, hopefully. Okay, end behavior, we're looking at two sides. We're going to look at this left side over here and this right side over here. Let's change colors. So left side, you start that statement by saying as x goes to, now x is unrestricted. This domain said it goes all the way to negative infinity. So as x goes to negative infinity, looks like the y's are forever going down. So you would say f of x goes to negative infinity. Okay, describing the right side starts out with as x goes to, how far right can it go? Forever, according to the domain. Then f of x goes to, okay, looking at this end, now we're shooting up, which means we're going to go to positive infinity. Okay, this graph right here, even, odd, or neither. Well, let's examine it. If I were to fold this graph on top of each other, as far as down the middle, would it match exactly? No, this portion over here on this side would now be on this side, right? And this portion would now be on this portion, and that would be completely backwards. So it is not even. If I took this function and I held a pin right here in the middle and I turned the whole thing 180 degrees, would I get the same picture? It is cubic, which normally is an odd function, but since we have moved it up to 3, it's no longer going to give you the same function, because this point right here is going to now become this point right here. So that graph isn't actually going to match up right there, if you can picture that. So this one's going to be neither. Oops. All right, increasing and decreasing. Looking at the graph, okay, starting at the far left point, domain says we can start at negative infinity and write our little choo-choo. We're going along choo-choo, and we're going uphill, right? Keep going, keep going, keep going. The graph might look like it flattens out there, but it actually doesn't. It's just slowly increasing. And it looks like he's going uphill the whole way, which means it's only ever increasing. Now, we said we could start at all the way over here at negative infinity. And if it's forever increasing, then it doesn't stop until infinity, which means there's nowhere that it's decreasing. As far as extrema goes, if it's always increasing and never decreases, then there can't be any extrema. Transformations. Let's see, we've got a +3 on the outside. So outside add 3, which means a vertical shift. Up 3. And we've got this 2 being multiplied in here, which is outside again, so it's going to be a vertical. We're multiplying by 2, that's a big number. It would make sense for that guy to be a stretch. And then you would say by 2. Okay, this one's 0.5 times the cubed root of negative x. So let's get a graph going up here. Okay, I'm just going to use Desmos because it makes it much more accurate than my cheesy little graphs, right? So we need to find, let's talk domain and range. So looking on Desmos right here, picture this line moving along, right? We've got a line and it's moving to the left. When does it stop? Well, it rides along that graph and it goes on forever and ever. So the domain goes all the way to negative infinity, and then if you move along the graph to the right, it goes on forever and ever to positive infinity. So the domain of this guy is going to be negative infinity to positive infinity. Okay, looking at the graph again, how low does it go? Well, it looks like it rides all the way down to forever in the bottom direction, negative infinity. And then it goes up, up, up over here. Right? That's kind of cool if you watch the point. See, as my x's get farther negative, my y's are slowly climbing and getting bigger and bigger. So it goes forever up to infinity as well. So my range is also negative infinity to infinity. Okay, x-intercept looks like it crosses right there. 0, 0, right? Turns out that that happens to be both the x and y intercepts. All right, and behavior. So we're going to have two as x goes to the left and as x goes to the right. As x goes to the right and as x goes to the left. Now I'm not writing infinity yet because we have to check according to our graph. So looking at that graph, if I go to the right and x keeps getting more and more negative, more and more negative, more and more negative to infinity, what are the y's doing? Well, they're getting negative and negative and negative and more negative. Since we know it goes on forever, that means as x goes to the right, which is where positive infinity is, f of x goes down, which is negative infinity. Okay, looking at the graph, if we're following along, and we've got this x value, and we're getting smaller and smaller and smaller x's, right, negative a bazillion or whatever, what are the y values doing? They were increasing. If you look at the graph, it goes on forever, and it's slowly climbing to the left. So we would say as x goes to negative infinity, comma, f of x goes to positive infinity that time. Even, odd, or neither. This one, if you cut it down the middle, it does not produce a reflection off the sides. But this is one of those that if you were to hold a spinner right here in the middle and turn the graph 180 degrees, you do get the exact same graph out. So this one would be an odd function. All right, should have changed color a while ago. Let's talk increasing and decreasing. So we look at our graph, and we're going to start over here, right? And we're going to say, choo-choo. Here's my choo-choo. He's riding this way, blah, blah, blah. Is he going uphill or downhill? Looks like my numbers are getting smaller and smaller and smaller. Now, do they ever stop and go up again? No, it looks like it's always decreasing. So we're only ever decreasing. That's going to be in terms of the x's, negative infinity to infinity, and it is never increasing. So for extrema, that means that there are no extrema because it never goes from increasing to decreasing or vice versa. Transformations, two changes have been made. We have multiplied outside by 1/2. Okay, outside means vertical. Multiply means either stretch or shrink. It's a 1/2, so it's got to be a shrink. And then you just say by what number you multiplied it by. And we've got this negative, and it's on the inside now. Trying to change signs, which means it is a reflection because it's over the y-axis. Sorry, because it's inside, it's horizontal, which is moving left and right. So this one would be over the y-axis. Okay.